Welcome to the fourth video in this series about inverse trigonometric functions. Here we're going to look at some composite functions that involve variable arguments instead of numbers. We'll just do one example. Suppose we're asked to find the tangent of the inverse sine of u, and we're not told anything about u other than it's some number that we don't particularly know the value of. Well, let's start, as before, by looking at the inside or first of the two functions in this composition. But what are we going to do with inverse sine of u if we don't have a specific number for u? Well, it turns out there is stuff that we can do with that. What that means, of course, is that we're looking for some arc length between negative pi over 2 and pi over 2, such that the sine of that arc length is this number u that we don't know. But watch what we can do with this problem even without knowing the value of u. To get a clear image, let's look at our unit circle here and consider the fact that if the sine of some arc length is u, then it must terminate at some point that has a y-coordinate of u, whatever that is. Well, it occurs to me that the picture may look a little different if u is a positive number versus if u is a negative number. After all, u represents the y-coordinate of the terminal point of some arc length, and so it would help to know if u is positive or negative. If u is a positive number, something here on the y-axis, let's just arbitrarily say, then it corresponds to some terminal point, which we could call P, and this here would be the arc corresponding to that terminal point. On the other hand, if u were negative, it would look somewhere down here, and it would correspond to a different point. We could call that P prime, and then our arc length would be represented by a negative number if we were in quadrant 4. And since we don't really know whether u is positive or negative, it wasn't told to us in the problem, let's start by doing the half of considerations where u is positive. We'll deal with the issue of u being negative in a few minutes. So assuming for the moment that u is positive, which they didn't tell us, but I'm just going to consider this case first, let's analyze the problem. For simplicity, let's call this angle theta. Now, to be clear, we can't find the value of theta. Theta represents the inverse sine of u. We don't know what u is, so we clearly don't have a specific value for theta. But what we do have is a picture of what theta might look like. And if I want to know the tangent of theta, even without knowing theta itself, couldn't I just do the sine of theta divided by the cosine of theta? Well, of course. But then, of course, the next question is, how do I compute those? Well, I don't compute them in a numerical sense. That's not possible without knowing a numerical value for u. But I can compute the sine and cosine of theta in the algebraic sense. In other words, in terms of the variable u. Watch how I go about this. The sine of theta is the y-coordinate of point P by definition. But we were told in this problem that that has a value of u. The cosine of theta, on the other hand, is the x-coordinate of P. And we don't know that, but we could find it using the fact that we know the y-coordinate. Let's take the equation of the unit circle. This is true for all points on the unit circle, including P. And let's substitute u for the y-coordinate. That's a fair assumption since P is the terminal point of the arc length inverse sine of u. Knowing that u is the y-coordinate of P, I can plug that in, and now I can solve for x, not numerically, but I can solve for x as a function of, or in terms of, u. Now, when I get down to the plus or minus involved in the radical, there's two things I should mention here. First of all, the radical is not simplifiable. Many students will attempt to write that radical as 1 minus u, thinking that somehow the radical cancels the u squared. But radicals don't distribute to two or more terms, and so there's no simplification that can be done there. Now to the issue of the plus or minus. X in this problem is clearly a positive number. In other words, the x-coordinate of P is a positive number because we're in quadrant 1. And therefore, I can eliminate the plus or minus consideration and just choose the positive one. And I now know the x-coordinate of point P. Well, back to my calculation on the left, cosine of theta being the x-coordinate of P can be replaced by that. But what have I done here? I have found the tangent of the inverse sine of some variable u without knowing a value of u, but rather getting my expression, or my answer, in terms of that variable u. That ends the consideration of what the result would be if u were a positive number. Now, let's consider the possibility that u is a negative number. If u is a negative number, that means that the point P has a negative y-coordinate. Call it P prime. But what one soon realizes is that all the work that you see here is exactly 100% the same if u is negative. And so I started this problem by saying, let's break it up into two cases, u being positive and u being negative. But if you look at over all of the work that's done here, all of this work would still hold to be true if u were a negative number. What does that mean? That means that this result at the bottom here holds for the tangent of the inverse sine of u, regardless of whether u is a positive or a negative number. And that's our example, and that completes this 4-video series on inverse trigonometric functions.